All right, so now this one, it says consider the quadratic equation, and it says use the discriminant to determine which graph could represent the equation. Well, we're going to graph it for sure and take a look at it, but what I want to do is I want to talk to you about the discriminant. So remember that when we solve this thing, we have x equals minus b plus or minus the square root of some stuff all over 2a. And the stuff that goes under here is b squared minus 4ac. Now, we've been very fortunate that when we go to take the square root of whatever this stuff in blue is, it's always been positive. We're going to come back to that in a second, but what I want you guys to understand is when we get an answer, we get like x equals plus or minus some number p, whatever it is. What that means when I graph this, if I get a number or if I get a number or two numbers, what that means is I'm going to have a value here, which would be like the negative p, or a value here, which would be the positive p, or whatever. There's a variation. Sometimes it has a square root, but we get a number, and those represent the x-intercepts, where it crosses the x-axis. And depending on the graph, that means that my quadratic equation will cross through. Remember, it's shaped like a parabola. It's U-shaped. Those 2 points, the solutions. So remember that the roots are the same as the solutions, and we also call them the zeros, right? Quadratics. Well, the interesting thing is, one thing we haven't really talked about is that sometimes this b squared minus 4ac can be negative, and we can't take the square root of a negative number. So sometimes you'll be asked, especially like on the SAT, to use the discriminant to determine if it has real number solutions or imaginary. Now, imaginary and complex numbers is how you deal with taking the square root of a negative number. So the discriminant then is this b squared minus 4ac. And it has two scenarios. If that discriminant is positive, be sure to write this down, is positive, then that means real number solutions. So if it says real number solutions, that means that it crosses the x-axis. Oops, not real number solve. Real number solutions, which means that it crosses x-axis. Now, if the discriminant is negative, it still has that parabolic shape. It just means that it does not cross the x-axis. That's all that means. And we would say that it has a complex solution. And complex solution, if you don't remember what complex numbers are, it's like a plus b times the imaginary number I, right? And that means that you have a real component and that you have an imaginary component. And what does that mean? Well, I is equal to the square root of -1. Okay? So we'll just keep that in mind. And what does that mean? Well, if that's a negative value, mean that it does not cross the x-axis. So with all that being said, let's see what our A, B, and C are. So I'm going to slide up here. A then is equal to 1, B is equal to positive 4, and C is equal to 5. Okay? So then when I go to solve the discriminant, I have B, which is B squared, which is 4 squared, minus 4 times A is 1, times C, which is positive 5. 4 squared is 16. Negative 4 times 1 is negative 4. Negative 4 times 5 is negative 20. And sometimes some textbooks will label this as a capital D. So the formula would be D for discriminant equals B squared minus 4AC. So then the discriminant is equal to, what's 16 minus 20? Negative 4. Okay. So it's negative, so that means it does not cross the x-axis. It still is a quadratic. And if I were to plug this in, I could solve this, but I'd have an imaginary or complex solution. What am I going to do? Well, to see what the graph looks like, let's just graph it in the graphing calculator. So turn your calculators on. And we are just going to graph this bad boy. And let me show you my screen a little bigger so you can see everything that I'm doing. Go to y equals, clear that out, and put in x squared plus 4x plus 5. We're going to hit graph. Oh man, my stuff's all messed up. So go to zoom, and I think we could do a standard fit on this. So just go hit the zoom button, and then option number 6 is zoom standard. All right. And let's see what we get. Okay. So it's still parabolic in shape, but notice that it doesn't cross the x-axis. So let's just take a screenshot of that, and then you guys could sketch that in your notes. So you're going to have multiple choice. One of them is not going to cross the x-axis. Does that make sense? So a lot of times, like if you're doing some fancy math, like if Mr. Adams does research or something like that, and I look at the data and I see that it doesn't cross the x-axis, or I don't, well, I got to back up a little bit. There's two scenarios. If I see that my data does not cross the x-axis, I know that I'm not going to have a real number solution. Does that make sense? Or if I'm doing the math and I calculate the equation and I realize it doesn't have real number solutions, then I know that the graph should look like this. Okay? Are there any questions on that? Okay, good. So the nice thing about the discriminant